This is the fourth video clip for the revision for the S3 assessment. It's calculator questions and it's at National 4 level. Okay, last video cut out a bit early, so we're going to go from question 22 onwards. That'll cover some things like volume, some problem solving volume, trigonometry, so that'll be SOHCAHTOA questions, some money questions, and also some perimeter and circumference questions with circles. And we'll always remember we've got the formula sheet at the start. Okay, right, so we're going to go to question 22. So Donna is a member of a fitness club. Her membership fee is £450 per year. Next year the membership fee will increase, so it's going to go up by 6.5%. What will Donna's membership fee be next year? Right then, so let's go ahead for this here. We're going to work out what the increase next year is going to be. So the increase is going to be equal to, so what it will be the amount that it costs this year, which is £450, and what I'm going to do is I'm going to multiply that by 6.5 and I'm going to divide it by 100, okay? Because what I'm working out is 6.5%, so this is what I'm actually working out, 6.5% of £450. So in my calculator, if I start with 450, I divide by 100, or another way to write that there would be 6.5 over 100 of £450. That's the way I can do it. Right, so on my calculator, I'll go for 6.5 divided by 100, and I'll multiply that by 450. So either this calculation or that one there at the top in the calculator. So the increase is going to be £29.25. So the membership fee for next year, so the fee next year is going to be equal to what it cost previous year, which was £450, plus the increase. Okay, from there I can just go to my calculator. I've already got the £29.25 in, and what I'll do is I'll add on to that £450. So that gives me a total of £479.25. Okay, so that's the cost of this year's membership. Right, moving on, we'll go to question 23. So question 23, the diagram below shows the inside of a speedway track. So the straights are each 100 metres long, so that would be this straight bit here, and if I go round the track, this bit here, so that's 100 at the top there as well. So this is going to be 100. The bends are semicircles as shown, so the bend is all the way around to there and all the way around from there to there, so two bends on it. And I'm going to calculate the perimeter of the inside of the track. So what I'm going to be doing here is I'm going to be working out this distance here, which will be the same as that distance, and add on 100 and 100. So that's what I'm going to do to find the perimeter. Okay, so first of all I'm going to work out the distance from there to there, the first semicircle. Okay, so I'm going to be using the perimeter, which will be the perimeter here of a semicircle is the circumference of the circle divided by 2. So that's what I'm going to do. And remember, that was just on our formula sheet here. So this is the one I'm using. So although it's the perimeter, remember on the circle it's the circumference. It starts with a C, so it's this formula I'm using, C equals pi d. C equals pi d. I'm halving it to find out that distance there. Right, so that's going to be equal to pi times the diameter. The diameter of the circle is all the way across. Remember, the radius is just half of that, but what I need here is the diameter, so that's going to be 70, and once I work that out, I'm going to divide it by 2. On to my calculator. Right, so I'm going to hit the pi button. So remember, the pi button is the shift button, and I've got this one down here where I can see pi. I'm going to multiply that by 70, and I'm going to divide that by 2. So what that gives me there is 109.9557, and that's going to be metres. So that's the distance from there to there. What I also know is the distance from there to there will be the same. So what I'm going to do to work out the perimeter, so my perimeter is going to be equal to, I'm going to have two of these, so I'm just going to write it down like this here. I'm going to add on to that another one of these. Onto that, I'm going to add on the 100, because there's 100, and add on 100. So remember, the perimeter is the distance all the way round. So if I start from here, I'm going to get to there, round to there, along to here, and back round to where I started. So that's a perimeter. So in my calculator, because I'm going to add two of them, I've already got that number in, so I'm going to times that by 2. There we go. So that's that and that added together. I'm going to add on 100 and add on another 100. What that should give me is 419. Okay, so what we'll do here is we'll get 419.91, and that's going to be in metres. So I'm just checking my units, the units up here. Let's just round it to the nearest metre. So the nearest metre would be cutting the number here. That 9 would make that 9 go up to 10, which kicks on to there. So it'll be 420 metres. Or this answer would be fine here. Okay. Right, so on to question 24. Right, question 24. What we have here, Phil was making a wooden bed frame. The frame is a rectangular shape. Okay, here we are here. It measures 195 by 95 centimetres here. To make the frame rigid, Phil is going to add a piece of wood along one of its diagonals. So from here across to here. Calculate the length of the piece of wood needed to fit along the diagonal. So this is the distance here that I'm trying to work out from there to there. I know if this is a rectangle, this will be a right angle that's sitting in there. And what I'm going to use, because I know two sides and I have to work out the other side, I'm going to use Pythagoras theorem. So by Pythagoras theorem. Okay. Right, because this is the longest side here, what I'm going to do is, I'm going to just call this x to start with, and I'm going to say that x squared, my longest side, is equal to one of the other sides squared plus the other side squared. So what I've done is I've got the two smaller sides, because remember, across from the right angle is always the biggest length. So I'm going to add. If I had to work out one of the smaller lengths, I would just change that to a takeaway, or just a subtraction. Right, let's go and work this one out. Okay, I've got my calculator. So 195, and I'm pressing my square button, or 195 times 195. That'll give me 38025. I'm going to add on to that 95 squared, which equals 9025. I'm going to gather them together. So I've already got that in the calculator. That plus that there, 38025 equals 47050. So obviously that's far too big to be that length there. I've got to remember that I've still to take the square root of that number there. Okay, because that's x squared. X squared equals that. I'm going to take the square root to find out what x is equal to. So I'm going to do the square root of that number there. That should give me 216.91. And that's working in, let's see, we're working in centimetres. Okay. Right, so I've got a bit of rounding to do here as well, so give your answer to the nearest centimetre. So my nearest centimetre is here, so if I cut that number there, that 9 is going to round to 6 up to a 7. I'm going to have nothing else after that. That's going to be my final answer. Okay, so that's my diagonal length. Moving on to question 25. Right, so a money question. Looks like currency. Andrew's on holiday in Canada. He has 600 Canadian dollars. He spends 565 Canadian dollars during his holiday. At the end of the holiday, changes the remaining Canadian dollars to pounds. Here's the exchange rate, how much will he receive? So let's start with how many dollars he has. Okay, so at the start, he has $600. Right, so he spends, so I'm going to take that away. What I'll do is I'll just bring out my calculator. Could do it without a calculator, but let's just make sure that when we've got a calculator there, we can check it and make sure that we get it right. So that's 35. So he's got $35 to exchange. So he's going to change this back into pounds. So when I change pounds into dollars, I multiply by the exchange rate. To change dollars back into pounds, I'm going to divide. So the amount of pounds is going to be equal to the amount of dollars that I've got, which is $35. Okay. And what I'm going to do is I'm going to divide that by the exchange rate, which is 1.74. From there, that should just give me how many pounds I'm going to get back. I've not got any rounding to do, so I'll just work that out in the calculator, see what that comes out to be. 35 divided by, we've got 1.74, gives me an answer of 20.1149. And let me just round that to the nearest penny. So that's really what I should be getting back, okay? On to question 26. So we go from there. Question 26. Right, so what we have here is we've got the floor plan of a concert hall. Okay. The stage is a rectangle. There's the rectangle part here. And the seating area is a big semicircle area there. Calculate the total area. So this is an area question that we're going to be working on. The area of the stage and the seating area. Give your answer correct to the nearest square metre. So we're going to be rounding just right at the end. I'll just bring up my formula list again. So I'm working out the area, and I've got a circle or part of a circle that's there. So the area, A is equal to pi r squared. So what I need to find out is the radius. So I'm going to do this part here first. So the area of the semicircle is going to be equal to, so that was pi r squared for a full circle. This is half a circle, so I'm going to then divide that answer by 2, okay, for the semicircle. Right, so I'm going to have pi, I'm going to multiply that by the radius. So let's see where the radius is, okay? So the radius should be going from here out to here, or I could go from there out to there. So another way I can find the radius is if I can find the diameter, so from here to here and half it. So my diameter is going to be equal to 4 plus that distance from there to there is 20 plus another 4. So that's going to be 28 metres. So my radius is going to be equal to the diameter divided by 2, which is just half of 28, which gives me 14 metres. Good, so I've now got what I need for my formula. It's the radius, right? So it's going to be 14 squared, and when I get that answer, divided by 2 for my area. Just going to go to my calculator. Right, in the calculator, I'm going to punch in the pi button first of all, the button down the bottom of the calculator, usually shift and pi. I'll multiply that by 14, and I can see my squared button just about here somewhere on most calculators. Squared divided by 2. So that there is going to be the area. Just go to there, okay? And that's going to be metres squared. So that's the area of this part here that we've worked out. Okay. Now I want to find out the area of that rectangle up above. So the area of the rectangle, okay, I think that's the stage, isn't it? The rectangle. I know that the area of a rectangle is just the length times the breadth. So I'm going to try and find the length. So the length of it, that distance all the way along there, is 20. I'm going to multiply that by the breadth, and the breadth is the size that's here, and I can see that's labelled up as 12. So that's 12. Okay. So again, what I can do is I can do that without a calculator, or I can just make sure I check it with the calculator as well. So that's 240 metres squared. Right, I've got two separate answers, one for this part and one for this part here. So the total area, which is what I've been asked to work out, I'm just going to add both of these together. So I've got 240 plus 307.876. Let's just add them together now. Okay. Plus 307.876. And what we get as an answer is 547.876, and that's going to be metres squared. Remember, what we've got to do is to round it to the nearest square metre. So I'm going to cut the number here. So if I cut it here, I'm looking to the right. That 8 will make the 7 go up 1 to an 8. So my final answer is going to be 548 metres squared. That's the answer. Right, we're on to a problem solving volume question here. Okay, it's involving, I can see in the question that I've already got some centimetres dimensions. I've also got litres, so I'm going to have to do a bit of problem solving here. So this empty tank is to be filled with water. The tank of the cuboid dimensions are shown here, okay? The water fills at a rate of 15 litres every minute. How long will it take to fill the tank? So if I've got a question like that to do, and I've got to find out how long it's going to take to fill it, I need to know the volume of the tank. So the volume of the tank, and remember it's a cuboid, it's going to be equal to length times breadth times height. Okay. So the length is 90, the breadth is 60, and the height is 50. I'm going to just multiply them all together on the calculator. Right, so let's go for 90 times 60 times 50. That gives me 270,000. 270,000, and that's centimetres squared. Okay, so the tank fills at 15 litres every minute. So 15 litres per minute, that would be, so if I'm looking to change 15 litres into centimetres cubed, what I'll do is, if I've got 15 litres, the way I'm going to convert that is just 15 times 1,000. What that's going to give me is 15,000 centimetres cubed. So I know that every minute I'm going to fill up that amount there. Okay, so 15 minutes I'm going to fill up that. Right, so the way I'm going to work out the time taken is going to be equal to the amount that I've got to fill, which is 270,000. I'll divide that by the amount it fills every minute, and what I'll do is that'll give me how many minutes it takes. So 270,000 divided by 15000 gives me an answer of 18, and that will be in minutes. So that's the final answer for that one. Let's have a look at question 28. Right, so question 28. A rectangular tennis court is 11 metres wide, so that's 11 metres wide. It has an area of 264 square metres. So the area that's taken up here, 264 square metres. Right, so calculate the perimeter of the tennis court. Right, this is quite a complicated question here. So what I need to do is to try to find out the length of that side first of all, so that I can work out the perimeter, because the perimeter's all the way around the outside, and to do that I need to know all the distances. I know this one here is 11 metres already, but I need to find that one. The way I'm going to find it is by using the area formula. So the area of a rectangle is equal to the length times the breadth. But here I can't put in the length and the breadth. What I will put in though is, I know that the area is 264. I don't know what the length is, but I do know what the breadth is, that's 11. So what I can then do to leave the length on its own, I can divide 264 by 11, and from there I should work out what the length is. Because remember, that's the length, I've not got a number that's going in there. So the length of the rectangle is going to be equal to, right, calculator again, what we'll do is we'll go 264 divided by 11, and that should give me 24. So that's going to be 24 metres, okay, so that's the length. So now I know that's 24, I know this one's 24, I need to just work out the perimeter. So the perimeter is equal to, so let me start here. So if I go along there, that's 24. If I go from there up to there, that's 11. If I go from there to there, that's 24. And then to get back to where I started, back to there, it's another 11. Okay. So let's just add that up in the calculator. So 24 plus 11 plus 24 plus 11, which gives me 70. I'm working in metres, so it's metres. It's not metres squared because it's just a distance that I'm trying to work out. Okay, let's do this question next, and this will be our final one in this session. So Kate is flying a kite, and she lets out 32 metres of string, so 32 meters of string to there, and it makes an angle of 65 degrees to the ground, okay? Calculate the height of the kite as shown in the diagram. Right, so from this question here, I can't use Pythagoras theorem because I don't know two sides to work out the other. I know an angle. If I see an angle in there, it's going to be a trigonometry question. Let's label up our triangle. Across from the right angle is the hypotenuse. Go to the angle. Opposite the angle is the opposite side, and the side that's left is the adjacent side, the A. I'm going to write up Socator. And what I'm going to do is I'm going to tick the bit I have to calculate. So I need to work out the height, which is O. So I'm going to tick O's. There we go. I'm then going to tick the other part that I know, which is the hypotenuse, the H's. So if I tick the H's, there we go, there and there. And I'm just going to box in these three letters. Remember, what we're doing here is we're just trying to find out which buttons on the calculator, either the sine button, the cosine, or the tan button, I'm going to use, and they're just lined up like that there. Okay. Let's now write down the sine ratio. So remember, the O is going up to the top, and the S stands for sine x, whatever the angle is equal to the opposite, because remember that's up the top, all over hypotenuse. Okay. Right, so what I'm going to do next is I'm going to fill in the values that I know. So the angle's 65. So I've got sine of 65 degrees. The opposite is this side here, so that's going to be the height. So let's call that just the height. Or you can call it x, okay? And what I've got is the hypotenuse is 32. From there, I'm going to say that to get rid of this 32 on that side, I'm going to multiply over here. So I know that the height is just going to be equal to 32 times the sine button, sine of the angle, is equal to the height. So the height is equal to, so let's just do that in the calculator. Right, so it's 32 times the sine button, opens a bracket on this calculator, 65, close the bracket, equals, so it's going to be 29.0018, and what I can do there is I can round that to the nearest metre, so it's metres we're working in here, so that's going to be 29 metres, and that's my final answer. Okay. Right, I'm just going to go over this and just do a quick double check on it. So what I did there was, again, so I set up the triangle, so that's the height, the the hypotenuse, opposite the angle is the O, the A is the one that's left here. Okay, what that does is it helps me work out the button I'm going to use on my calculator. Is it the sine, the cosine, or the tan button? What I've got here is I've ticked the O's because that's what I'm trying to work out. The O's, tick the H, the H. That directs me towards the sine button. I write down the sine ratio. So S means sine x, C means cos x, T means tan x, but it's the sine x I'm going to use here. Opposite over hypotenuse. What I've got is the sine of 65. I'm going to put in the h here for the height, okay, or I could have made that x if I'd wanted. And what I've got is 32 for the hypotenuse. Fire it into the trig ratio. Work it through, so getting rid of this here, 32 sine 65, and what that does is it gives me a final answer of 29.0018. Rounded to the nearest metre, it's going to be 29 metres. And that's the end of this video. Hope this has helped you, this series of videos has helped you prepare for the assessment. Good luck.